Hey guys, this is 6-1 polynomial functions. We're going to look at simplifying and classifying polynomials. Alright, so before we get started, let's take a look at, the definition. Alright, so polynomial function is any function that has at least one term with an x, and it could be power of 1, it could be greater, and it can also have a coefficient. The exponent in term determines the degree of that term. So the highest exponent that you have determines the degree. And you have to put that in standard form, which means that you put them in order from the greatest degree, the greatest polynomial, to the least degree, the smallest polynomial. So the leading coefficient is the number in front of the variable. This is 2x cubed, so it's degree 3. This is negative 5x squared, so it's degree 2. Negative 2x, so that's degree 1. And this is a constant, so it is a degree of 0. So we have them in order, descending order, degree 3, degree 2, degree 1, degree 0. This is the cubic term, this is the quadratic term, this is the linear, and this is the constant. Anything above cubic, we would just say degree 4, degree 5, and so on. And we did visit this in Algebra 1, but it's been quite some time. All right, so here is a little chart. It is in your textbook if you want to use that as a reference, and I would encourage you to do that. But also make sure that you are able to differentiate between the degree and also the term names. So if it has degree 0, it's constant. If it's degree 1, it's linear. 2, quadratic. 3, cubic. 4 is quartic. 5 is quintic. It is degree 6, degree 7 if you go above that. This is where I was getting those wires crossed. And then naming it by the number of terms we have. If it's a single term, it's a monomial. 2 terms, binomial. 3 terms, trinomial. And then 4 and greater, polynomial of the number of terms that we have. Okay, so let's go ahead and take a look at example 1. Example 1, classifying polynomials. First, you want to put it in standard form. Then classify it by the degree and by the number of terms. So it has to have 2 classifications. Okay, so negative 7x plus 5x to the fourth, well, that's degree 1. That's degree 4, so the 4 comes first, which is why it's written as 5x to the fourth minus 7x. So that is in simplest and standard form. This is degree 4, so then that means it is quartic, which you see down here, and there's 2 terms, which means it's binomial. B, we have 1, 2, 3, 4 terms, but we need to simplify them, so we may or may not have 4 terms at the end. X squared, negative 4x, plus 3x cubed, plus 2x. 3x cubed comes first, x squared comes second, and then you have negative 4x and positive 2x. So simplifying that by combining like terms gives you negative 2x, which is what we have here. Oops, sorry. So 3x cubed plus x squared minus 2x. So this is degree 3, and there's 1, 2, 3 terms. So this is a cubic trinomial. All right? So now let's take a look at the ones for your notes. Well, heavens to Betsy, I have no idea where that went. All right, so we'll take a look at the ones for the quick check. We have 4x minus 6x plus 5. So combining these, we have 4x minus 6x, which gives us negative 2x, and then you have plus 5. This is in standard form because this is degree 1, this is degree 0. And since that's degree 1, we know that this is linear. And because there's 2 terms, it's a binomial. So this is a linear binomial. Okay. B, we have 3x cubed plus x squared minus 4x plus 2x cubed. Well, 3x cubed and 2x cubed are like terms, we also need to combine those, and it's also the largest degree within that term, because this is 3, 2, and 1. So 3x cubed and 2x cubed is 5x cubed. Then we have x squared, and that's positive x squared, and minus 4x. Okay, so this is degree 3, right? So I'm going to write that, degree 3 and terms 3. So this ends up being a cubic trinomial. And then C, we have 6 minus 2x to the fifth. Well, this 2x to the fifth has degree 5, this has degree 0. So this term comes first, which is negative 2x to the fifth plus 6. So it's a degree of 5, and there are 2 terms. So this is a quintic binomial. You do need to give it this formal name. It's not a bad idea to identify how many degrees and how many terms you have to help name it properly, but at the same time, you have to have this official name. All right, we're going to look at a few more examples of classifying polynomials. These are associated with the second part of your assignment. The numbers are a little bit bigger, and so for some of you that might be a little bit more challenging, and you might think that you don't have an example that goes with that. So I'm going to go ahead and do this. Now, in this case, this is an addition of polynomials. So therefore, this has no effect on the sign. If this had been negative, we would have to distribute that negative across and change the signs of everything. But since this is positive, we don't. So I'm going to go ahead and just remove the parentheses since it doesn't pertain to this particular problem. And just rewrite that. So 30x cubed minus 49x squared plus 7x plus 50x cubed plus a negative 75 plus a negative 60x squared. And again, putting that plus in front of those doesn't change the sign, so we're just going to leave it alone. Now we want to look at like terms. Well, this has x cubed. This has x cubed. This one has negative 49x squared, and this one has negative 60x squared. This one has x, and that's it. And then this one is a constant. Okay, so we have 4 different terms, or 4 different types of terms here. 30x cubed plus 50x cubed is going to give you 80x cubed. So we're done with those. Then we have negative 49x squared and negative 60x squared, which gives you negative 109x squared. And then 7x minus 75. So we now have degree 3, and we have 1, 2, 3, 4 terms. So this is a cubic polynomial of 4 terms. Okay, so that's what you would write for that particular one. Okay, so now B, a little bit different than what we've seen so far, but definitely something that you can do. This says to the power of 2. So what that means is we have 2 of those binomials, a minus b times a minus b. If that had been a minus b cubed, then we would have 3 of those, but it's squared, so we have 2. And then you have that a plus b. So now the question may lay with, where do you begin with this? So what I would encourage you to do is just do these first 2 together, or do the first 2, simplify that, and then distribute that last binomial to it. Again, if you don't remember the rule about the perfect square binomial, a squared minus 2ab plus b squared, you can do FOIL firsts outers, inners, and last. So that gives us a squared minus 2ab plus b squared. Okay? And then you take this trinomial and you have to multiply it to the a plus b. Right. So then you do a squared times a, so that's a cubed, a squared times b, so that's a squared b. Then you have negative 2ab times a, so negative 2a squared b. Negative 2ab times b is negative 2ab squared. B squared times a is ab squared. And then b squared times b is b cubed. All right, so now we need to go through and simplify them. A cubed is considered your leading term. So that means we're going to simplify in decreasing degrees of the a's. So a cubed, a squared, a to the first, and then a to the 0. That is the standard acceptable form for this. All right, so we have a cubed, a squared b minus 2a squared b is going to give you negative a squared b, because that's 1a squared b minus 2a squared b. Negative 2ab squared plus ab squared is going to give you negative ab squared. And then you have plus b cubed. All right, so this is the term that we have. And again, because a is the leading term, that's what we're going to classify this by. So this is degree 3. And there's 1, 2, 3, 4 terms. So this has the same official classification name as the one we did above. This is a cubic polynomial of 4 terms. Okay, now finally, let's take a look at this example C, 2C, to be more specific. And again, we're going to start by multiplying these two binomials together. 2c times 2c is 4c squared. 2c times 4 is 8c. Negative 3 times 2c is negative 6c. And negative 3 times 4 is negative 12. Now we take this polynomial and we're multiplying it by the 2c minus 1. I got a little sloppy there. So we have 4c squared times 2c, which is 8c cubed. 4c squared times negative 1, so negative 4c squared. 8c times 2c is 16c squared. 8c times negative 1 is negative 8c. Negative 6c times 2c is negative 12c squared. Negative 6c times negative 1 is positive 6c. Negative 12 times 2c is negative 24c. And negative 12 times negative 1 is positive 12. Okay, so now we need to combine like terms. We have, oh goodness gracious, I suppose I could have simplified there, couldn't I? And I didn't see it. All right, so we have 8c cubed minus 12c squared. Nope. Back that up. All right, so we have the 8c cubed, then we have negative 4c squared, positive 16c squared. And then we have negative 12c squared. And then we have negative 8c, positive 6c, and negative 24c. And then we have this plus 12. Sorry about that. Okay, so that gives us 8c cubed. And then we have 12c squared minus 12c squared. So these actually cancel each other out. Negative 8c plus 6c gives us negative 2c. Negative 2c minus 24c is negative 26c. And then we have plus 12. All right, so now looking at this one, we have a degree of 3, and we have 1, 2, 3 terms. So this one ends up being a cubic trinomial. All right, guys, that's it. Hopefully this makes sense. It's not hard. It's just obviously tedious, especially with some of the larger binomials or some of the more in binomials. If you have any questions, let me know.